Hey everyone, Mr. Hartley here. I'm just going to be trying to make a bunch of videos, see how they work as far as keeping up to date with the curriculum stuff that I want you to know and that you kind of need to know. Today I'm going to start off with, I'm going to do some short videos, so this one's going to be review for you guys. So I'll go through it quick, and if you want to take notes or whatever, you can always pause this as it goes along. So you've seen this before, looking at the development of the atomic theory. And what we have here is kind of the beginning. So we start out with our Greek philosophers, and they all kind of came up with some interesting ideas. There is actually one guy who came up with kind of the right idea, but unfortunately everybody kind of laughed at him. And for centuries, we believed the theories that everything on our planet was made up of these four constituent elements: earth, air, fire, and water. And if you could take all of those, you could form everything else. Now that lasted for quite a long time, even though we started finding elements. And we moved on until finally we get to this English guy, Dalton. And Dalton comes up with the theory of the atom. And this is kind of the first starting point of the atom. And he's trying to disprove all the alchemists and everything, and say, hey, wait a second, we can't change atoms of one element into another or anything like that. They're kind of stuck. And so he basically thought that everything could be broken down into its smallest particle, and the atom is the smallest particle, and that's why he named it the atom, because that actually means first, the word atom. So here's his postulates. Atoms are the smallest indivisible particles. He says, well, all of the atoms are the same but different from other elements. And then he said, atoms of one element can't be changed into atoms of another element. And then finally, he says right here, atoms combine in whole number ratios to form compounds. And he likened it to a billiard ball. And so that's your billiard ball model. And from here we move on, because actually 3 out of his 4 postulates are incorrect, and only 1 is actually correct. So we get to the next thing, and basically we have students of his or understudies that help out with his studies, and they find out new things. So we get to Thomson, and Thomson here tried some new experiments, and he actually is going to be coming up with a theory and working with more students and so on, and they will disprove him as well. So each guy kind of gets his starting point, and it leads to the next. So we're building on the knowledge of one professor to the next. So what he ends up finding out is that atoms aren't the smallest thing, and there's actually charged particles, and he noticed there's a different mass related to positive and negative charges within the atom. And so we end up with these things, electrons, negative electrons, that have small amount of mass, and then the positive part had a large amount of mass. So this is what he proposed: big giant positive goop, negative stuff stuck in the middle, and we get our raisin bun. Now, of course, I like to liken it to a chocolate chip cookie and a raisin cookie, because when you get a raisin cookie, you get those, you think it's a chocolate chip cookie, and you bite into it, and you get that awful feeling of, oh, I made this terrible mistake. This is not chocolate chips. These are raisins. What a negative experience. And so think of those raisins as the electrons. We move on to the next one. We get the Bohr and Rutherford, and there's a little Canadian content here with Rutherford because he studied over at McGill under Thomson, and they actually ended up doing this amazing gold foil experiment, which showed that electrons are tiny, but protons, or the positive part of the atom, is actually quite small as well. And in fact, atoms are mostly empty space with these tiny particles moving around. And so we have Rutherford and Bohr coming up with similar ideas that kind of work together. So there's those two theories, a beehive and a planetary, moving into the Bohr-Rutherford model. And so from here we get into how do we figure out Protons in an atom. This is, you look at the atomic number on the periodic table. How do you get the number of electrons in an atom? It's the same as the protons, and it's the same unless you have an ion. And if you have an ion, it means you have more or less electrons. And so this gives you a positive or a negative charge. And from here we get to cations and anions. Cations are positively charged, and the way you remember that, cats have paws. Anions are negatively charged, and so you remember it, a negative ion. So how do we determine the number of neutrons within the atom? Because that's the last part that makes up the mass of the atom. And you just subtract the atomic number from the atomic mass. Be sure to round to the nearest whole number. So here's the rules for making a Bohr-Rutherford diagram. You can see that right there. And of course at the bottom I say the rest holds a total of 8 for now. So let's try it with potassium. So we start with the nucleus, and in the nucleus we look for the protons on the periodic table, which is the atomic number. The atomic mass minus the atomic number gives us 20 for the neutrons. And then for the shells, you look how many rows down it is on the periodic table. So if I look on the periodic table here, it's 4 rows down. So I'm going to put 4 things on the outside of the atom here. And then in each shell, we have the first shell can hold 2, the rest can hold 8 for now. So the first shell has 2. So how many do we have left over? Well, we've got a few more left over. So we are going to show that there's 2 in the first. And seeing as there's a total of 19, we have 8 in the second. We still have some left over, so fill it up with 8. That gives us a total of 18. We need 1 more. So there it is in the last shell. And so that's the Bohr-Rutherford model. Okay, from there, we move on to the Lewis dot diagrams. And here's a quick summary of them. I'm not going to talk about them much. And then I'm going to show you examples on the next page. And there they are. Notice it's just the outside shell. And notice the number of dots corresponds to whatever group the elements are in. Okay, I'm going to stop for there, and I'll give you another note in a little while. Thank you. Bye-bye.